Welcome back to AP Statistics. Again, I'm not affiliated with the College Board. I teach at a high school where they call me Dr. Kling. And today's topic is conditional probability. So we're still talking about two events, not necessarily independent. And we'll call them A and B, and I'll keep using the same events. A is the Redskins make the playoffs. And B is their coach gets fired. Okay, the definition of conditional probability, we can write the probability of B slash A is defined as the probability of A and B over the probability of A. So this little slash here is an indication of conditional probability. Conditional probability, that's what that slash means. It means the probability of B given A. That is, or if A occurs, what is the probability of B? So the probability of B given A. So given that the team makes the playoffs, what's the probability that the coach will be fired? And that's different from the probability of A and B. So the probability of A and B is the joint probability, and we will use words like and, both, and together. The probability of A slash B is conditional probability, and we will use words like if, of, or given. So let's use our example. In our example, we said that A and B was 0.1. And I think we said probability of A was 0.3. That's the probability they make the playoffs. Probability the coach is fired is 0.4. Okay, so the probability of B slash A, using this definition that we have up here, is the probability of A and B, which is this guy, 0.1, divided by the probability of A, which is this guy, 0.3, is equal to 1/3. Okay, so that's so if the team makes the playoffs, the coach has only a 33% chance of being fired. We can also calculate the reverse conditional probability. We can calculate the probability of A given B. So if you told me that the coach got fired, I can then tell you what I think the probability is that the team made the playoffs. So suppose I wasn't following the team, which I sometimes don't, but after the season you told me that the coach got fired, I can form a probability that the team made the playoffs. And that is probability of A and B over probability of B is equal to 0.1 over 0.4, or 1/4. So there's a 1/4 probability that if the coach got fired, then the team made the playoffs. Okay, so not very likely that the team made the playoffs if the coach got fired. So there are, in some sense, if we go back to our box, remember we have A, AC, B, Oops, I don't want to put that there. Let me get rid of that. I want to put B over here, the letter B, and BC. Okay, so inside each section of the box, there are two conditional probabilities. So let's focus in on this one. So, and I represent each conditional probability as a triangle. Remember, inside here is probability of A and B, and I put that at the top of a triangle. So, probability of A and B, and then we have probability of A given B times probability of B. I'm saying times because that's the way we're going to use this triangle. And we have another triangle implicit in there that is implicitly in here, where that's probability of A and B over probability of B slash A, B given A, times the probability of A. So in equations, this triangle represents an equation that I wrote up there somewhere. No, I didn't write it, so let me write it out fully down here. Probability of A and B equals the probability of A given B times the probability of B. That's this one. And then we have this one, which is probability of A and B equals probability of B given A times the probability of A. So that's what these triangles represent, and so we can think of them, the triangles, as existing inside the box. So what can that do for us? Well, it can do for us the following. Suppose we make up a different problem, or in fact, let me pause and make up a different problem. Okay, here we go. We're going to have two events about voters. Event A is that the person voted Democratic. Event B is the person was a member of a minority group. And we'll suppose that the probability of A is 0.5, probability of B is 0.2. Then I'll give you this weird conditional probability information. If 60% of non-minority voters did not vote Democratic, what percentage of voters were minority and voted Democratic? So we're trying to find the probability of A and B, and we are given this weird conditional probability we're given, this is, let's see, of non-minorities. So it's slash BC, that's of non-minority, and this is not Democratic, so it's AC, and that's equal to 0.6. Okay, so how are we going to do this? Let's start with the box. And we'll reproduce some of this information in the box. Okay, so we'll draw a box, and we have A, and we said the probability of A was 0.5. We have AC, we have B and BC, and B we said was 0.2. That was 20% were minorities. And then we've got something often that helps us in this quadrant because it's got AC and BC in it. And what we'll do is we'll use the triangle. We can find this thing, which is AC and BC, from AC slash BC and BC. Well, what's BC? BC, if these have to add to 1, is going to be 0.8. Okay, and so we now know that we're going to multiply the two things at the bottom of the triangle to get what's at the top. And so BC is 0.8, AC given C is 0.6, so 0.6 times 0.8 equals 0.48. So now we have a 0.48 here, and now we can fill in the rest of the box. I'm going to subtract and get 0.02 there. I'll subtract and get 0.32 there, and we get 0.18 there. And that is the answer that we're looking for, the probability of A and B. That is 18% of voters were both minority and voted Democratic in this hypothetical example. So that's how we do the simple math of conditional probability. And next time we'll talk a little bit more about conditional probability in terms of independence and something called Bayes' theorem.